All right, we're going to be talking in lesson 9-5 about polygons on the coordinate plane. And yes, I have graph paper up because we're going to be graphing, right? Today's date is 4/10/19. Okay, so what's going to be happening on this particular problem is that they may be telling us the coordinates, or they may be drawing a figure, and our job is to figure it out. Now, you've seen a couple problems like that where I had several people say, I don't know how to figure it out. They didn't tell me how much it was, but they drew it on a coordinate plane, and all we had to do was count how long or how high each of our shapes were. So we have two strategies we're going to be using when we're given coordinates of a figure and asked to find the perimeter and area. So let me write that out. When given coordinates of figures, so coordinates are the location of the vertices, the points, and are asked to find the perimeter and the area. There are two ways to solve. Okay, so first way is we're going to draw it and count. Since we're on graph paper, that is a necessity. So this way demands we must have real graph paper. Okay, otherwise our counting may be off. Okay, the second strategy is to use the coordinates to determine lengths, widths, and height. I guess we could say bases too, right? Okay, so I'm going to go ahead and give our situation. We're going to talk about finding perimeter on this page, and on the next page we'll talk about finding area. So yes, I used 2 pages on this particular assignment. So let's deal with perimeter first. And it says a rectangle with vertices. So vertices, again, are where the sides of the polygon meet. Oops, let's put the name of that point as A, and it's located at 2, 8. B, and it's located at 7, 8. C, that's located at 7, 5. And D is located at 2, 5. Okay, so we're going to use the coordinates to find the length of each side. That's how we figure out perimeter. We find the length of each side and then add them up. And then find the perimeter. And we're going to be dealing with a rectangle in this particular case. Again. Then find the perimeter of the rectangle. Now, we're not always going to be dealing just with rectangles, but for this case, yes. Okay, so we have 2 methods, and we're going to demonstrate how to do the same problem. Draw it. Method 1. That looks like method L. Let's see if I can method 1, draw it. Okay, so I'm going to draw my coordinate plane. Let's see, I need to go up. Let's see, this would be 2, 2, 2, 2. Let's see how far I need to go. 8, 7, 6, 5, 4, 3, 2, 1. And if you notice, all our coordinates were positive. And then 1, 2, 3, 4, 5, 6, 7, 8. Let's shorten that a little bit, shall we? Okay, and then we'll write every other number. 2, 4, 6, 8, and then I'm going to start graphing. So let's see, A was at 2, 8, and see how easy this is because I'm just looking for the intersections of the graph paper. B is at 7, 8. C was at 7, 5. And D was at 2, 5. Connect them together. Now I know you guys have been wondering, when am I ever going to do a special word? So today, our secret word is wind, because I can hear it blowing outside. Wind. All right, so what I'm going to do is count. So let's see, 1, 2, 3, 4, 5. So this is 5, 2, 3. So this is 3, and opposite sides would have the same measurements. Okay, so from here I can determine that the length is 5 and the width is 3. So to do perimeter, I'm going to have 2 times the length plus 2 times the width. 2 times the width of 3. So that's going to give me 10 plus 6, which gives me 16. So I would say the perimeter is 16 units. I didn't tell you whether it was inches, feet, meters, miles, so we're just going to say 16 units. Okay, honestly, with the wind right now, for me, I thought it was raining. Nope, just windy. Okay, let's talk about method 2. And that's going to be use the coordinates. So I won't even draw a picture of it. So what we need to do is look at 2 ordered pairs and look at their x coordinates and look at their y coordinates. Okay, so 2 situations can pop up. We could have y coordinates that are the same. So if the y coordinates are the same, we're going to subtract, a little yelling, the x coordinates. Now it wouldn't make sense to subtract the y coordinates because if they're the same we get 0. So we want to subtract the other set of coordinates, the x ones, to find a length. And then if x coordinates are the same, again, we're going to subtract the opposite coordinates, the y coordinates. To find a width or a height. Oops, didn't quite spell that one right. Okay, so let me demonstrate what I'm talking about. So in our original pairs, we had two vertices that had the same y coordinates. So let's do x's first. Let's do that. Now let's do y's. Flibberty gibbet, there I am. So let's look at the y's. So the two guys that had the same y value was A and B. So A was at 2, 8. B is at 7, 8. So according to our directions, if the y coordinates are the same, we're going to subtract the x coordinates, okay? Because we have matching y's, we're going to take the x's and subtract them. So I'm going to get 7 take away 2 equals 5. Okay? And if you look at the other coordinates, 7, 5, 2, 5, so that's your CD, then the same thing would happen. So let's see. C is at 7, 5. D is at 2, 5. So again, my y's match. So I'm going to subtract my x coordinates. And again, get 5, which makes sense because these 2 points, they're going to be opposite each other. So we're going to determine and say, okay, that's going to be length. So length equals 5. Okay, and we could say units, but for right now it doesn't matter. So let's look at the x's. And let's see where we have x coordinates are the same. So with the x values, we had A and D. A is at 2, 8. D is at 2, 5. So here, my x's match. So I'm going to subtract my y values. And notice that I'm always going to take big number, take away small number. Another set where my x's match would be B and C. And we have 7, 8, 7, 5. My x's match. So then I take my y's and I subtract them. And then I say the width is equal to 3. Okay? So then if I want to figure out perimeter, let's see, I'm going to put it right here. I'm going to get 2 times the length of 5 plus 2 times the length of 3 equals 10 plus 6, or 16. So it's the same exact answer. So 2 strategies to get the same thing. So you can draw it, count it, calculate the perimeter that way. You could figure out the opposite value when you had matching coordinates. So matching x's, you could figure out the y's value. Matching y's, you can figure out the x value. And you're going to get 2 sets of sides that have two sets of sides that have the same measurement. So 2 5s and 2 3s. All right, let's try area. Okay, so here we're going to find area. So what are we going to do? Number 1, determine the dimensions. So we have 2 strategies. We choose which one we want to use. Oh, I forgot a letter there, didn't I? That would make sense. And the second thing we're going to do is substitute the dimensions. into the formula and solve. By the way, don't forget, write that special word, wind, at the top of your notes. Okay, so, we're going to draw a really interesting shape. Ooh. Directions are going to ask us to find the area in square units. So let's see, we're going to go. Apparently, there's been a bug that's been found. Yeah. A lot of screaming going on. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Oh my gosh. Sorry about that. If you can hear that. It's loud. Oh my gosh. Here we go. So we're going to put one at here and one here and then 7, 1 and 7, 3. So we're going to have a rectangle shape. And then on top of that rectangle, at 2, 3, we'll put another point. And then at 2, 5. And then at 5, 5. And then we're going to come back to 7, 3. Okay, so what I've got here is a weird shape. There's no name for the overall shape that I have. So what I'm going to do is I'm going to break it into 2 separate shapes and figure out the area of each of the shapes and then combine it all together. So first thing I have is a trapezoid. Okay, so trapezoid has 3 dimensions we need to know. First, we need to know the bases, 1 and 2, and then the height. Okay, so base 1 would be from here to here. So I count 1, 2, 3. Base 2 is going to be from here to here, and I count 1, 2, 3, 4, 5. Height is going to be here, perpendicular to the bases, okay, and that count is 2. So I'm going to put that into the formula for the area of a trapezoid, and I get area is 1/2 the sum of the bases, B1 and B2, times the height, and I just plug numbers in. So my bases are 3 plus 5, and then I'm going to multiply that by the height, which is 2. So just to conserve space, I'm going to continue the problem over here. And I get area equals 1/2 times 8 times 2. So I'm going to take half of 8 is 4. 4 times 2 is 8. So I get the area is 8 square units. Okay? But I'm not done because that's only part of what that figure looked like. The second one appears to be a rectangle. So I'm just going to go ahead and count. And the 2 key things that I need are a base and a height. So let's look at the base. So we go, that's 1, 2, 3, 4, 5, 6. And for the height, 1, 2. Okay, so the area of a rectangle follows the same idea as what we have for parallelogram. I could say W and L for these two things as well. So I'm just going to say area is equal to base times height, because all rectangles are parallelograms. So I'm going to go ahead and substitute my numbers in, and I'm going to get 6 times 2. And to conserve space, I'm just going to continue over on the right, and I get A equals 12. So that's the area. We get 12 square units. But we're not done yet, because remember, we need to put it together to make the entire shape. And that's going to be the area of your trapezoid plus the area of your rectangle. Okay, so for us, that's going to equal 8 plus 12, which is 20 square units. Okay, now what's interesting is we're going to deal with this concept a little bit more tomorrow night. Okay, let's do one more example. This time I'm going to give you coordinates. A figure has vertices, ooh, that's a weird S, A at 2, 5, B at 2, 8, and C at 5, 8. Okay, so already I'm thinking 3 vertices, it's got to be a triangle, but I don't know. But look what they tell us. We need to graph it. So we're just not going to use the coordinates. We're going to do graphing. So graph the figure and classify it. In other words, tell me exactly what it is. That's what classify means. And then find the area. So I draw a graph. 2, 3, 4, 5, 6, 7, 8. So 2, 4, 6, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 6, 8. Now I'm going to graph this. A is at 2, 5. B is at 2, 8. Oh, I'm going to have to move that A, aren't I? Here's B. And C is at 5, 8. Okay? So, let's talk about the classify part. Now, we can be simpletons, and that means give out just the basic information, or it could be as specific as possible. So, first off, I know it's a triangle, but let's see if I can figure out what kind of triangle. Well, when I look at the angle, I know that's a right angle, so I know it's a right triangle. Okay? When I count up 1, 2, 3 from B to C, 1, 2, 3 from A to B, that tells me 2 sides are the same number in a triangle. That makes it isosceles. So its official name is an isosceles right triangle. Okay, so now that we know it's a triangle, let's figure out its area. That equals 1/2 the base times the height. Start substituting numbers in. I get A equals 1/2. Now, how my numbers work is one of them is the base, and the other is the height. And the reason why I know that is because these guys form the right angle. So what I get is, remember we talked about if you only have odd numbers, multiply them first. So I get a half times 9, which equals 9 halves. And the only thing that I need to remember to do is to turn it into a mixed number, because it's a measurement. So 2 goes into 9 4 times, which is 8 with 1 left over, and the remainder is 1 half. So what I have is the area is 4.5 square units. Oops, there we go. Hello. All right, there we go. See you later.